Good morning, one and all. This is Aditya from BSc-IT batch 2, and I am standing here in front of you to find a equation of a line which is passing through a given point and parallel to a given vector. So before starting my onboard presentation, I would like to thank Ravinder sir to giving me this golden opportunity to stand here in front of you and find the equation of line which is passing through a given point and parallel to a given vector. So here we have a line which is L and another line which is M, which is parallel to L1 line, and on a L line there is a point P and whose coordinate is x1, y1, z1, and another point A which is x whose coordinate is x, y, z, and it is the origin. And if we have said that OA vector, this is OA, and OA vector, pause कर. Now OA vector equal to, here we can see that OA vector equal to R1 vector, which is basically x1 I cap plus y1 j cap plus z1 k cap, and OP vector which is basically equal to R2 vector, and R2 vector equal to x2 I cap plus y2 j cap and z2 k cap, and the line M1 whose vector form is AI cap plus bj cap plus ck cap. And here we can see that the line L1, it means AP is parallel to M1, so we can written here. So we know that when in vector, when two lines are parallel to each other, then we can written as AP vector is equal to a scalar multiple of M vector. Here where lambda is a scalar multiple. Now lambda is a scalar multiple, and now again we can here find a position vector of AP. Basically, a position vector of AP is a position vector of P. Position vector of P minus position vector of A is equal to lambda into M vector. Now basically, what is position vector of P? Position vector of P, that is OP, which is basically OP vector minus position vector of A. Now position vector of OA is that position vector of A, which is OA, and lambda into M vector. Now OP vector basically equal to R1 vector minus OA vector. Now OP vector basically equal to R vector. Here you can see that OP vector equal to R vector minus OA vector. OA vector basically equal to R1 vector. Now we can here written R1 vector and lambda into M vector. Now R vector equal to R1 vector plus lambda into M vector. Now this is the equation. Now this is the equation of line in vector form. Now we can find the equation of line in Cartesian form. Now nothing is here that we can only expand this R vector, that is R vector equal to and R1 vector equal to x1 I cap plus y1 j cap plus z1 k cap plus lambda into M vector equal to A अरे सर, B j cap plus C k cap. A cap plus B j. Now we can solve this equation. Here x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap. And here we multiply both by lambda. Yeah, it means lambda A I cap plus lambda B j cap plus lambda C k cap. Now equating both sides in I, j and k coefficient factor. And we retain here we x I, it means the coefficient of I is lambda x a, and here the right side the coefficient of I is x minus x1 vector. So we equating both of them. X minus x1 is equal to lambda a. Then lambda is equal to x minus x1 upon a. And y minus y1 equal to y minus y1 equal to lambda into b. Then lambda is equal to y minus y1 upon b, and z minus z1 equal to lambda into c. Then lambda equal to z minus z1 upon c. Now this is from equation 1, 2 and 3 we will get x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. Now this is the equation of a line in Cartesian form. So thank you from my side. Thank you.